Good morning. Welcome to the third lecture on economics, management and entrepreneurship. Today, we are going to talk about elasticity of demand. Before that, I would like to go through the slides that I presented in my last lecture on market equilibrium. This was done in the last lecture, that was on demand and supply that exists in market equilibrium. I will quickly go through these slides once again, so that we can give the new ideas in the lecture 3 on elasticity of demand. Here we first gave certain definitions of market, demand, supply and market equilibrium. Then we said that there can be different types of competition, perfect competition and imperfect competition. Most of our discussion will be assuming that perfect competition exists in the market, and then we gave different characteristics of the different types of competition. We talked about demand as being direct demand for consumption or derived demand. Then we talked about demand function. There we said that demand is a relationship between the quantity demanded in the market and such other factors like price, price of other goods, income, so on and so forth. This is an example of a demand function. Then we talked about demand curve, where we said that the demand is a function of price alone. Normally, as price increases, demand for the product falls. So, this is an inverse relationship between demand and price, which is called the law of demand. This is given by a straight line with a negative slope. We can show the demand curve as being shifted from its nominal value when certain other factors other than price is different from the one at which the original demand curve was plotted. Similarly, we talked about supply function, an example of supply function. Then we said that supply curve is the relationship between quantity supplied by the firm or by the industry and the market price alone, and not assuming all other factors that affect the quantity supplied to be fixed at certain specific levels. And normally, when the price increases, there is a motivation for the firms to produce and supply more to the market. So, the slope of the price supply curve or the supply curve is positive, and the effect of other factors can be shown by shifting the supply curve either to the right or to the left. And then we said that market equilibrium exists when the demand of the market and the quantity supplied to the market, they equal. This is what we did in the last lecture. Today, we talk about elasticity of demand. Basically, elasticity of demand will indicate how much the demand will change, or what fraction or what proportion demand will change for a unit percentage change in one of the factors. So, here we will learn a few things. First, the concepts of elasticity of demand. In that context, we shall define point elasticity and arc elasticity. We will introduce total revenue, marginal revenue and average revenue, and then we will introduce various types of elasticity of demand, such as price elasticity of demand, income elasticity of demand, advertisement elasticity of demand, and finally, cross elasticity of demand. So, let us take up these concepts one by one. As I showed you just now, a demand curve is basically it will have a negative slope. We are assuming a straight line relationship between price and demand. So, the equation of this particular line will be P equals A minus B q, and then q can be expressed as a function of P. So, it is A divided by B minus 1 by B into P, the price, Q is the quantity demanded in the market, and assuming A divided by B as alpha and 1 minus B as beta, we get quantity Q as equal to alpha minus beta into P. Now, this is the demand curve equation expressing quantity demanded as a function of price P. So, from here we find out the first differentiation of Q with respect to P, which is basically the slope of the supply curve, and that is equal to minus beta. Beta being positive, minus beta is negative, and therefore, the supply curve has a negative trend. We defined demand elasticity as a measure of sensitivity of the demand to a change in one factor influencing the demand, assuming that other factors remain at certain specific values. So, basically we will try to find out as 1% change in the factor brings in how much percent change in the demand Q. So, basically it measures the percentage change in the demand due to 1% change in one factor. So, other factors are held constant at specific values. We assume any other factor as x affecting the quantity demanded Q. Assuming this, let us develop the expression for demand elasticity, that is, we are trying to find out or estimate the percentage change in Q demand when 1% change is made to one of the factors x. Now, in this context, we define two types of elasticity: point elasticity and arc elasticity. Point elasticity is basically percentage change in Q divided by percentage change in x, the factor. So, it is basically fractional change delta Q by Q divided by fractional change in x delta x by x. Multiplication 100 in the numerator and multiplication 100 in the denominator cancel out, leaving only the fractional changes delta Q by Q divided by delta x by x. So, basically we are trying to find out here, if we give a 1% change in x or one fractional change in x, how much fractional change in Q occurs. Now, this can be written as delta Q by Q divided by delta x by x, which is equal to delta Q divided by delta x multiplication x by Q. Now, we said it is a point elasticity because this requires a value of x and q to be known at certain point. At that point, the slope is to be calculated, and therefore, this is the elasticity at that point in the demand curve. And normally, when there is a very small change in the value of x, for example, the fractional change is about 5%, the percentage is only just about 5% in the factor x. This is considered to be a small change occurring at the existing value of x. So, there point elasticity is relevant. However, when we bring in a substantial change in the factor x, and conventionally suppose that the fractional change is more than 5%, we consider that change to be substantial. When that happens, we no longer go for point elasticity computations. We consider that the change is substantial. Therefore, we try to find out the change that has occurred from the existing value q 1 to a new value q 2 as a result of the factor x changing its value from its initial value of x 1 to its final value x 2. It is defined as the change divided by the average value of q divided by the change in x divided by the average value of x. 2 cancels out, leaving q 2 minus q 1. We bring in x 2 minus x 1 from here to the denominator and take q 2 plus q 1 to the numerator here, and then division. Therefore, this becomes multiplication, this comes to the denominator. So, the arc elasticity is defined as q 2 minus q 1 divided by x 2 minus x 1 multiplication x 2 plus x 1 divided by q 2 plus q 1. This is normally known as arc elasticity. Whenever the change in the factor is more than 5%, we consider it substantial and apply this expression for arc elasticity, and when the change is small, less than 5%, we apply the concept of for the equation of point elasticity. Now, in the earlier slide, I just said a factor x without mentioning what that factor is. Let us now consider that that factor is price, which means that we are now interested to know what is the price elasticity of demand. That means, we are interested to know if a change of 1% is given to price, then what is the amount of change or what is the percentage change in the quantity demanded. We designate this as epsilon p, epsilon for elasticity and p for price elasticity. Using the previous equation, it is delta q by q divided by delta p by p. So, percentage change in p and how much percentage change in q. Now, if we assume the demand curve to be continuous, then we can take this as the first derivative of q with respect to p. So, instead of writing del q, delta q and delta p, we can write ddp of q, that is the first derivative of q with respect to p, and division q by p or multiplication p by q. same thing. When we multiply, P will come to the numerator, Q will go to the denominator. Now, assuming that the relationship between Q and P is a straight line relationship, we give Q as equal to alpha minus beta P. This is a straight line relationship with a negative trend, as we know, minus beta. So, Q is equal to alpha minus beta P, and if we take the first derivative of Q with respect to P, we get ddP of Q as equal to minus beta. Beta being positive, minus beta becomes negative. Therefore, dQ dP is always negative, meaning that as price increases, quantity demanded falls, as we know from our earlier knowledge on the demand curve. Now, knowing the value of dQ dP as equal to minus beta, we can find out the price elasticity epsilon p. Epsilon p from our first equation is ddP of Q divided by Q by P, which becomes equal to this one, which is dQ dP multiplication P by Q. And now that we know that dQ dP is minus beta, this then becomes minus beta into P by Q, and since P is positive, Q is positive, beta is positive, but minus beta makes it negative. Therefore, epsilon P is negative. This means that the price elasticity of demand epsilon P is always negative. So, and from here we can also have an intermediate result which we shall use later, which is that Q divided by beta, we take this to the left hand side, Q divided by beta is equal to minus P divided by epsilon P. So, this comes to the denominator, this goes this side to the numerator, beta comes here. This is an intermediate result that we shall use in our next slide. So, here we learn that price elasticity of demand is always negative. As we know, as price increases, demand falls. So, the price elasticity of demand is expected to be negative, which is so as we have seen in this case. Now, before we go further, we would like to now define certain other concepts of total, average and marginal revenue. Total and average revenue first. Total revenue is the total sale in terms of rupees per year and is given by the quantity sold multiplication unit price P. That is the total sales revenue or just sales or total revenue, also called only revenue. So, basically we are assuming here that whatever quantity is demanded, it is also sold at a unit price P rupees per unit into Q is rupees per year, making it P into Q, and that is TR, total revenue. If total revenue is P into Q, the average revenue will be equal to TR divided by Q, which is equal to P. It is given by the total revenue divided by the quantity demanded. So, average revenue is equal to P when price changes do not occur. Now, here let us relate the total and average revenue and bring in the concept of MR. MR is here and that is marginal revenue, which is basically defined as first derivative of total revenue. It says derivative with respect to Q. That means, for unit change in the value of Q, what is the rise in the value of total revenue, that is d dq of TR. Unit change in Q gives rise to how much change in total revenue, that is called the marginal revenue. Now, total revenue as we know is equal to unit price into quantity demanded or quantity sold P into Q. Now, we assume or we have already shown that P is equal to alpha divided by beta minus 1 divided by beta into Q. So, P into Q becomes alpha by beta Q minus 1 by beta Q square. Now, marginal revenue, as I said, is the first derivative of TR with respect to Q. So, taking the first derivative of this expression, we get this as alpha divided by beta minus 2 by beta Q. This can be written as alpha divided by beta minus 1 by beta Q, put that within the parenthesis, and 1 by beta Q we bring it outside, and this is nothing but this, which is equal to P. Therefore, we can write this as P and we can write this as minus Q upon B. So, marginal revenue is equal to P, the unit price, minus Q divided by beta, and by a previous result, we have already seen that Q divided by beta is equal to minus P divided by epsilon P. Epsilon P is the price elasticity. Now, this result we now use here. Q divided by B is minus 1 by epsilon P, and minus makes it plus. So, we see we get a relationship between the marginal revenue and the price elasticity of demand, and it is related to in this fashion, it is 1 plus 1 divided by epsilon P. Now, we already know that price elasticity is always negative. We have already seen that as price increases, demand falls and epsilon P is negative. Therefore, this quantity is negative, and therefore, MR is negative. MR is less than P, but P is equal to average revenue. Average revenue is total revenue divided by Q. Total revenue is P multiplication Q, that divided by Q is equal to P. So, we can write a relationship between MR and AR with the use of epsilon P. So, marginal revenue is equal to average revenue multiplication 1 plus 1 divided by epsilon p, and as I told you, epsilon p is always negative, and therefore, MR is less than AR, because it is AR multiplication 1 minus something. So, it is AR minus AR into something. So, it is always less than AR. Now, use this relationship further and let us analyze what happens when epsilon p takes different values. Now, we will discuss elastic and inelastic demand cases. Here, first of all, we see that MR is always negative and less than AR, and MR is equal to dQ of TR. That also we know. Now, if epsilon p mod value is equal to 1, then what happens? Epsilon is negative, therefore, epsilon p, if it is mod value is 1, then epsilon p is minus 1, and therefore, 1 minus 1 makes it 0, and therefore, MR is equal to 0. So, MR is equal to 0, and TR, if MR is equal to 0, then what is the meaning of TR? TR remains constant, because the dDQ of TR is equal to MR is equal to 0. This means that TR is constant. It means that even when price changes, the total revenue does not change. Now, this is the case of unit elastic demand. That means, when price increases, the demand falls in such a manner that price into demand remains constant. Price into demand equals total revenue, that does not change. This is the case of unit elastic demand. Now, we take the next case, which is epsilon p mod value is less than 1, and we already know that epsilon p is negative. Now, it takes a value, if mod value of epsilon p is less than 1, then it is MR has to be less than 0, and TR therefore, will fall, which means that as price increases, the total revenue will fall, and this is a case of inelastic demand. We will explain these things in more detail little later. Now, take the case of the mod value of epsilon p is greater than 1. Epsilon p is greater than 1, but epsilon p is negative, the mod value being greater than 1, this quantity MR will rise, and the demand therefore, is elastic. Now, let us take the limiting cases. The limiting case, two cases are there. One is a demand is perfectly inelastic, and the other case is that the demand is perfectly elastic. In a perfectly inelastic demand case, the mod value of epsilon p is taken as equal to 0, whereas in case of perfectly elastic demand, the mod value of epsilon p is taken as infinity. Now, in this case, when we say that the demand is perfectly inelastic, it means that the firm can change any price and sell the same number of units. That is, the demand curve is vertical. No matter what the price the firm sets, the number of goods that it can sell will always remain constant, a perfectly inelastic case. The other extreme is the perfectly elastic case, where epsilon p mod value is extremely high. It means that the firm can sell an unlimited amount at the market price, but if it changes its price anything from the market price, anything different, then its quantity comes to naught, 0. This means that it is a demand curve is completely horizontal. Now, let us look at these first two are the limiting cases of perfectly inelastic demand and perfectly elastic demand. This says, the first diagram says that no matter what price a firm makes for its good, for its product, it can always supply and sell the demand, the quantity, same quantity. This is a case of perfectly inelastic demand. The demand does not change, price is changing, but the quantity demanded in the market is not changing. This is very unrealistic case, but this is a limiting case. Here on the other hand, we are saying that at some price P, the market, the demand, the firm can supply any amount of demand, but if it changes its price, then the demand becomes 0. That means, it is a case where the demand is extremely sensitive to price change, perfectly elastic demand case. And this is a case where I said the same percentage change in price leads to same percentage change, 1% change in price leads to 1% change in the demand. Therefore, the total revenue remains constant, total revenue which is P into Q remains constant. This is P and this is Q. P Q remaining constant is basically a rectangular hyperbola case. For this situation, the total revenue will remain constant no matter what the price is set. Price may be made more, in that case demand will fall. So, that price into demand is constant, and if price falls, demand is more, price falls, demand is more, the multiplication of price and quantity remains the same. So, these two are extreme cases, and this case can occur, but in reality there are many situations where the demand is elastic, the demand is also slightly inelastic in case of items that are considered as necessity items. Say for example, food materials, even if the price is increased, the demand for food materials does not fall to that extent. So, to a large extent the food materials are inelastic in nature. Now, this slide gives an explanation of these three cases. Effect of 1% change in price. Here we are saying that an inelastic demand results in less than 1% change in the demand for a 1% change in the price. That means, if we change the price by 1%, suppose that we reduce the price by 1%, the increase in the demand is not by 1%, but less than 1%. This is a case of inelastic demand. Here marginal revenue is negative, and when price is reduced, the quantity sold increases, but because the marginal revenue is negative, the total revenue declines. Similarly, or rather unlike this, in an elastic demand case, the demand is elastic. It means that when a 1% change is made in the price, this leads to more than 1% change in the demand. This is the case of elastic demand. Here the marginal revenue is positive, and when price is reduced, this is an example, when price is reduced, the quantity sold increases as it should following the demand curve, and also unlike in the case of inelastic demand, the total revenue increases. Now, in the case of unitary or unit elastic demand case, the marginal revenue is 0, the total revenue is maximum. Now, here in this slide we shall illustrate that along the different points of the demand curve, the price elasticities would differ. With a concrete example, we are illustrating this case. We are first of all assuming that the relationship between quantity demanded in the market or quantity sold in the market and the price, unit price, is a linear function with a negative slope 25 minus 2.5 p. Therefore, taking the first derivative, dq dp is equal to minus 2.5, which is less than 0. Now, I have taken 2 points. Let us take that this is the first point. If price is 2, then putting this value here, 2.5 into 2 is 5, 25 minus 5 is 20. Therefore, the demand is 20. So, this is the point of price 2 and quantity 20. Now, at this point, if I calculate my point elasticity, the equation is dq dp multiplication p by q. Now, already we have found out dq dp, that is equal to minus 2.5. So, this value I put here as minus 2.5 multiplication the values of p and q at this point. P is 2, this one, and q is 20. So, I put minus 2.5 into 2 by 20, which is minus 2.5 into 1 by 10, which is minus 0.25. So, the point elasticity at the point 210, price 2 and quantity demand 20, 2 and 20 is minus 0.25. Now, consider another point 3, this point, second point. At second point, let us say that the price is more and that is equal to 3. So, if price is 3, then the corresponding value of the quantity will be 2.5 into 3 minus 7.5, that brings it down to 17.5. So, as price increases, demand falls. So, if the demand falls, we once again now use the same equation for finding the elasticity at that point 3 and 17.5. Price equal to 3 and demand is equal to 17.5. As before, dq dp equal to minus 2.5, this one, this one, this one. Multiplication, the value of p is 3 and the value of q is 17.5. Therefore, 3 divided by 17.5 is equal to approximately equal to minus 0.428. So, we see that at different points in the demand curve, the elasticity of demand changes. In fact, at this point it is more negative than at this point. Now, suppose that we consider a substantial change from 2 to 3 as substantial, is actually 50% change from 2 to 3. So, the change is delta x 3 minus 2, which is 1 divided by 2, 1 by 2, which is 50% change. Now, if there is a 50% change in price, this is considered a substantial, and for such a substantial change we should not apply the concept of the point elasticity. Instead, we should use our arc elasticity concept. Arc elasticity, if you recall, the corresponding equation is the change in Q divided by the change in the price multiplication average price. Of course, 2 has is eliminated, 2 by 2 divided by 2 here, divided by 2 here, they cancel out, leaving P 2 plus P 1 and division Q 2 plus Q 1. Now, in this case Q 2 minus Q 1 is 17.5 minus 20, which is minus 2.5. P 2 minus P 1 is 1 from 2 to 3. So, this is P 2, 3 minus 2 is 1, multiplication addition of the 2 is 5 and addition of the 2 is 37.5. This value comes as minus 0.33, lying somewhere between these two values. So, this slide tells you or gives you a concrete example of how to calculate the point elasticity and the arc elasticity. Now, we go further. We are assuming that the demand is a function of price and that we are trying to find out how much, what fraction or what percentage the demand changes for a unit percent change in price. That is called the price elasticity of demand. Now, the price elasticity of demand values will differ from one good to another good or one product to another product. Say for example, we have a product which we consider highly necessary for our daily life, such as food materials. compared to a product, let us say a car or a television or an air conditioner, which is probably a luxury to certain society. Now, if the product is a necessity, then a change in the price of the product, a small change in the price in the product will not change the quantity so much, because we need it as a necessity of life. So, this is a case of inelastic demand. Demand does not change much as price changes, but if the car price rises, then probably the demand in the market may fall. So, these are situations or cases where the price elasticity figures can change from type of good, from one type of product to another type of product. Price elasticity will also depend on the availability of a substitute. If, for example, the substitute, there is a substitute for a product that you are manufacturing and its price reduces or falls, then it is likely that your product demand will be affected, because many demands in the market will be met by your competitors who sell the substitute product. So, your demand for your product will fall. Therefore, if in the presence of substitutes, elasticity values would differ from product to product. The third is the proportion of income spent on the product. If families spend a large percentage of their funds for the product under consideration, that will have one type of elasticity value compared to when the family spends less. Now, there are different other types of demand elasticities. Let us spend some time. We had been talking about only price elasticity of the demand. We will now consider different other types of elasticity. In particular, we would like to talk about these three types of elasticities. 1. Income elasticity of demand. 2. Advertisement elasticity of demand. 3. Cross elasticity of demand. As you know, in general, whenever a factor value changes by a certain fraction or percentage, the elasticity of demand can be calculated to find out how much percent change occurs in the demand. That is the elasticity of demand. Now, when that factor is income, we call it income elasticity. When that factor is advertisement, we call it advertisement elasticity, and when that factor is a substitute or a complement, then we call it cross elasticity. Just as we had defined price elasticity as del q by q divided by del p by p, here we say it is delta q, del q or delta q by q divided by delta I by I, where I is the income, disposable income. In case of advertisement, it is delta q by q divided by delta A by A, where A is the amount of advertisement expenses. And this is, as I said, this is the another product's price, particularly as I have told you, a substitute product, let us say, or a complementary product, its prices change, and to what extent the quantity demanded for your product changes. for a unit or a 1% change in the price of another product which is a substitute or a complement or another product in general is called the cross elasticity of demand. Let us elaborate these cases in some detail. Income elasticity of demand, it measures the responsiveness of demand to changes in income holding all other variables constant, and if this elasticity is positive, that means it is expected that as income increases the demand should rise, and if this elasticity is positive, this is called a normal or a superior good, sales rising with rising personal income, and that normally occurs when economic growth occurs. This is income elasticity. Advertisement elasticity of demand, it measures the responsiveness of demand to changes in advertisement expenditure holding all other variables constant. Usually this elasticity is positive, as we know. It is expected that as we increase our advertisement expenses, the awareness in the market about your product rises, and therefore, the quantity sold in the market or demanded in the market rises. So, we expect this elasticity to be positive. Now, if its value is greater than 1, it means that sales rise more than proportionately with rising levels of advertisement expenditures. Now, we come to the cross elasticity of demand. It measures the impact of the prices of a substitute or a complement on demand. Now, this is an example of what we mean by substitute and what we mean by complement. Let us say that the product in under consideration is tea that a company is manufacturing. The substitute for tea in the market is coffee. Now, if coffee price goes up, then the demand of tea is likely to go up, because as the price of coffee rises, the demand for coffee reduces, demand for tea rises, and therefore, price of tea is expected to also go up. This is the case of positive cross elasticity of demand. Now, consider a case of petrol and car. Car is the product under our consideration. To run a car, we need petrol, which is prepared or which is sold by another company, and that is a complement. Petrol is a complement of car. Now, if petrol prices go up, then it is likely that the demand of car may go down. This is a case of negative cross elasticity of demand. Whereas, if two products are unrelated, the cross elasticity is 0. Gentlemen and ladies, basically we introduced to you the concept of elasticity of demand, where we said or where we wanted to quantify or measure, give a measure of how much fraction or how much percentage change is brought about in the quantity demanded for 1% change in one of the factors, when all other factors are assumed to be held constant. We gave certain examples, we gave certain illustration, particularly saying how point elasticities are calculated and how arc elasticity is calculated. We also gave examples of different factor elasticities, price elasticity, income elasticity, advertisement elasticity, and finally, cross elasticity of demand. In this context, we also defined substitutes and complements. Thank you very much.